I'd like to welcome Eddie Habibi as our webinar speaker today. Eddie is the founder and CEO of PAS Global, and he's also a pioneer and thought leader in the fields of industrial control systems, cybersecurity, industrial IoT, data analytics, and operations management. In 2017, PAS was recognized in CRN's 15 coolest industrial IoT companies, and Eddie was listed by CRN as one of the 30 Internet of Things executives whose names you should know. He is the co-author of two popular best practices books on operational risk and safety management, namely the Alarm Management Handbook and the High Performance HMI Handbook. Eddie holds an engineering degree from the University of Houston and an MBA from the University of St. Thomas. So with that, I'd like to welcome Eddie, and I'll turn it over to you now.
Thank you, John. Thank you for the introduction, and I'm delighted to be here. I imagine you are as diligent and effective as a professor as you were as a scientist and a technologist when you worked with us here at PAS. Today, I would like to talk with everyone about cybersecurity and the threats of cybersecurity in the operational technology environment for the critical infrastructure. You will hear me interchange the terminologies of operational technology, OT, industrial control systems, ICS, and automation systems. Generally speaking, these are conveying the same set of systems. And of course, we're going to narrow our focus to what are some very first steps you must take in protecting your operational technology assets against cyber attacks. With that, what I'd like to do is just have a conversation about what cyber assets are. We'll look at the agenda here. Operational technology asset management. We'll define what OT systems are and what the asset management of these systems means. We will talk about cybersecurity and the impact of a sound, robust asset management strategy to protect against cyber attacks, challenges in that arena, and then strategies to improve and secure control systems leveraging an asset management strategy. Automation systems in their current form have been around since the mid-70s. These are microprocessor-based control systems, originally referred to as distributed control systems, programmable logic controllers, collectively process automation systems. In recent years, we have adopted a new term that is operational technology to collectively refer to these systems. People also interchangeably use industrial control systems to define the same things. These are systems that control the critical infrastructure. The critical infrastructure spanning oil and gas industries, chemical industries, power generation, power distribution, paper mills to automotive manufacturing, just about any place where you have automation. In fact, outside of critical infrastructure, you have automation in your home, your basic temperature control system at the house, or control systems for lighting and environmental controls in large commercial buildings are also automation systems. Automation systems also play a very important role in helping protect process plants against abnormal situations and inadvertent safety issues. They, in a way, protect lives. They are there to protect the workers in process plants from bad things happening. The Purdue model, which most of the chemical engineering and control engineering students at BYU should be familiar with, encompasses 5 layers as defined a couple of decades ago to encompass field instrumentation. These are the instruments that interface to the plant assets. They give life to the otherwise electromechanical devices that run a process plant. These could be pumps and compressors. These could be distillation towers where we measure temperature, pressure, flow, level, etc. Then we have process controllers that include the I/O, the input-output channels, as well as the controllers themselves, where the logic resides. HMI is the human-machine interface where some of the advanced applications as well as the operator interfaces are. The MES layer, the manufacturing and execution systems layer, is where some of the high-level advanced applications like the historian or as well as other applications like multivariable controls run. Business networks encompass the level 4, and enterprise networks and the cloud make up the level 5 of the Purdue model. Now, what is unique about industrial control systems, process control networks, is that there are 2 layers that make up the entire ICS. One is the IT layer, that's level 2, where the HMI, the SCADA systems, and the configuration stations are. These are typically Windows operating system servers that connect to the proprietary side of the ICS, the OT, and those are level 0 and level 1. There are many differences between the 2. One that stands out is the number of devices that are on the IT side of the industrial process control networks. These are IT-centric devices, as I mentioned, servers, typically run in Windows, but they can also be Unix, Linux-based, and otherwise. They do have IP addresses, and they are agent-friendly. That is, you can run executable programs on these devices. They are easier to scan and access using standard Windows calls and APIs. They make up generally about 20% of what you will find in an industrial control systems environment. On the other side, you have the OT proprietary layer. These are production-centric. We call them production-centric because they directly connect to the physical plant and digitize, if you will, the physical plant. They give us visibility to what goes on in the field in terms of measurements, as well as providing actuators to impact the process. They're generally multi-vendor. They come from Honeywell, Invensys, Emerson, Yokogawa, and other suppliers. And they are generally proprietary. That is, these systems have their own configuration, they have their own operating systems, they have their own programs that run, and you cannot run foreign agents or foreign programs on these systems. They are very sensitive to scanning. You could overload them and shut them down if you put too much demand on them. And they are more difficult to access and more difficult to understand what is within them. Each system, as I mentioned, has its own method for accessing information. Other aspects of IT and OT that highlight the differences include the asset life cycle. The asset life cycle of an operational technology system, an industrial control system, can span 15 to 30 years, whereas an IT system goes through a revamp, a refresh, every 3 to 5 years. If you look at your laptop or your server, within 3 to 5 years, you need to upgrade to a new hardware platform as well as upgraded operating system to keep up with the high demand that new applications and databases put on these systems. By contrast, these operational technology systems can be in place for 2 or 3 decades. The priorities of these systems, what we expect out of them, their utility is also different. Whereas IT systems generally are concerned with confidentiality, the integrity of the data, and the availability of the data, operational technology systems are inherently there for safety, availability, and reliability. So how we prioritize them becomes different. The consequences of an incident are different. If there are mistakes or if there are attacks on the operational technology systems, there could be safety consequences up to loss of life. Whereas with IT, it is denial of service or loss of information, totally different categories of consequences. Patching operating systems and applications is another area where there is tremendous difference between these two systems. It is not unusual for us to upgrade the operating system or applications on our laptops. In fact, on your iPhone or on your friendly device, whether it's Samsung, iPhone, or others, it's not unusual to update apps every other week or so. However, on the OT side, a system can go 2 years without ever going through an upgrade because most of these systems require a reset or a shutdown before you can upgrade them to a new latest version of the operating system or a patch. And of course, in a 24/7 critical operation, you can't have that. So you wait until a turnaround or until you have had an accidental shutdown to bring your patches up to date. Scanning these systems is also different. Active scanning is normal on IT systems, looking for vulnerabilities, looking for an inventory of these systems, what devices you have. Whereas on OT systems, you can't put significant load on these systems by actively probing the devices that are on these systems. Another area of difference is the maturity of these systems as it relates to cybersecurity. IT systems have been designed to deal with cybersecurity issues for decades, at least 2 decades, whereas OT systems are less mature when it comes to cybersecurity as well as other aspects of enterprise information technology, such as openness to running agents and applications, as well as interconnectivity and interoperability. Both of those are loaded terms, but basically, if you have Oracle talking to Windows, talking to an Aspen accounting system, they all talk to each other. But on the OT side, you have to have specialized interfaces, so the maturity is not there. The OT assets are primarily those devices, those controllers that run the plant. They are responsible for 2 very, very important things. One is the safety of the process. The other is the production, the automation of the process. They are practically the heartbeat of the plant. The entire knowledge of production resides in the ICS. The entire safety practices related to the process reside within the ICS. So the reliability of these systems becomes very critical. A plant shutdown at a mid-sized chemical or refinery can cost a company tens of millions of dollars. And when things go wrong, people do actually get hurt. And this is not meant to sensationalize. I don't think you have to look very far to see the impact industrial accidents have on people's lives. We have had them here in Houston, not too far from our offices. Whereas when there is an incident with an enterprise technology system, enterprise IT, the worst thing that can happen is your server gets shut down, you lose data, or information gets stolen. People don't normally get hurt. OT assets contain that configuration, which I mentioned a few minutes ago, that make operations possible. The OT assets come in a variety of flavors, if you will, distributed control systems, safety instrumented systems, historians. Each one of these device types have a very specific purpose, and they have to be available for a plant to operate. They include RTUs, PLCs, and others. The configuration of these systems is the brains that enables automation, enables production, enables safety, as well as environmental compliance. You have production management layer applications. You have advanced applications such as multivariable controls and optimization and the historian, basic process controls, as well as sensors, aka IoT. IoT, of course, has become quite popular in the broader Internet of Things, in the broader enterprise asset management these days. But We in the process controls arena have been dealing with industrial Internet of Things for over 3 decades. The three components, the three basic elements that define IoT are sensing capabilities and actuation, sensors, communication, networks, Wi-Fi, internet, and lastly, advanced applications, artificial intelligence, advanced process controls, optimization applications. These three components come together to define what makes IoT, whether it is the systems that keep my Tesla within the lane at the speed that I'm trying to operate, or that advanced applications that optimizes the performance of a distillation tower in a refinery. Collectively, we have generally referred to this as process automation. Now we have a new term, and that is IoT. The most difficult aspect of cybersecurity today is gaining visibility to the first component of industrial Internet of Things. That is level 0 and level 1 of automation. We looked at level 0 and level 1 previously in the Purdue model. These are sensors and controllers and I/O cards. And if you walk up to a process plant and ask the responsible personnel, whether it is the automation people or operations or safety people, cybersecurity people, whether they can detect changes at level 0 and level 1, at, for example, the logic within a PLC, it is really difficult for people to answer that because there has not been a unified approach to managing the configuration of automation systems. Configuration management for IT has been around for 2 decades. It's a standard practice that IT organizations follow. However, you don't have that in the ICS or the operational technology arena. If you were to ask a process plant whether they can tell you what has changed in the last 24 hours, it is very difficult for people to answer that. And finally, understanding what inventory of devices you have and how are they interconnected at level 0 and level 1, companies have a difficult time to answer those questions. Now, you have to ask, why are these questions so critical to cybersecurity? They are fundamental to a robust cybersecurity strategy because if you do not know what devices you have on your industrial control system, you cannot protect them. So the first step in understanding what you have, in understanding your security posture, is to understand what devices you have and what the configuration changes are on these systems, what configuration baseline you might have. So the relationship between asset management where configuration management is the core aspect of an asset management strategy is very important to highlight here how that is related to cybersecurity. If you look at some of the seminal accidents in the processing industries, going back to the Bhopal gas leak in India, this was a Union Carbide company that released isocyanate, methyl isocyanate, very, very early morning back in 1984, led to many fatalities. And basically, if you look back, it practically put Union Carbide out of business. Union Carbide was later acquired by Dow. Not to sensationalize this, but the error was basically lack of proper maintenance of the IoT assets. Valves that were leaking, transmitters that were not picking up signals, and the defeated safety systems, equipment failure, ultimately human error due to lack of procedures and automated systems to monitor the entire automation in that enterprise. Piper Alpha, another change management initiative, another change management issue that led to a terrible, terrible accident with significant number of fatalities and significant cost on an oil platform. Again, lack of adequate procedures, lack of adequate process hazard analysis, but most importantly, lack of proper management of change. Storage complex in Buncefield in the UK, another explosion that was again due to lack of proper management of change in the configuration of the control systems. The BP refinery, not more than 20 miles away from our offices in Houston, south of Houston in Texas City, was another terrible incident with terrible losses that was primarily due to lack of proper maintenance, lack of configuration management, lack of understanding of the IoT, enormous damage to the community. Again, lack of understanding of what devices we had, lack of understanding of the configuration of these devices. Alarms were bypassed, measuring devices, sensors were decommissioned and in repair and not taken care of. That led to this terrible accident. So automation assets in general are there to protect process plants. They are there to enable automated production. And when they are not managed properly, the production suffers, shareholders suffers, and people suffer. There are additional risks. Now, every one of those incidents that I mentioned on the previous slide were due to human error. You could write them off as human error, ultimately human error. They were failures of humans to put in place proper procedures and proper systems, proper training to make things happen, the proper things happen. However, we have a new enemy, and the new enemy is cybersecurity. The new enemy encompasses hackers. The hacker community can include ransom hackers as well as nation state. We have seen growth in attacks on industrial control systems because they control physical assets, and what is at risk is has tremendous consequences, including safety of personnel and loss of production. Threats are on the rise, attacks are on the rise, and we have seen them increase. There is significant awareness right now in the industrial sector about these attacks. I'm not going to go through each one of these attacks, but some of them I'm very familiar with, where in one case a disgruntled employee went in after he had been released for 2 weeks. He was getting back into the system with his privileges and altering the controls in this paper mill, causing tremendous damage. Now, fortunately, that led to an arrest as well as fining and jail time for this individual, but others have gone unpunished, namely nation states. We have proven records, documentation from the FBI and ICS CERT, attacks on the critical infrastructure, penetrating our utilities through eavesdropping, social engineering, gathering information, and these nation states continue to be active in their attacks on the critical infrastructure. What is most unsettling for me is that we don't know where these vulnerabilities exist today. That is, the attacks have taken place. We have uncovered many of them, but there are other attacks that we are not aware of, and there are other infiltrations that we have not discovered. And there are some basic measures that companies can take to assess their OT assets and identify their vulnerabilities, and that is what we will cover in just a little bit. But first, we have to talk about some of the challenges that we face as we try to manage OT assets. First thing is that these are very disparate systems, and they're very complex systems. They come from a variety of vendors. I've been in this industry for over 30 years, and in my over 30 years, I've never been to a process plant where they had all of one kind of automation systems, that is level 0, level 1, level 2. Companies over the years have adopted best-in-class technologies, and that means a hodgepodge of systems from different vendors from different generations. These are very complex, they are very proprietary systems. They were not inherently designed to document themselves very well, so the knowledge of these complex systems is in the heads of individuals who walk out of the plant at the end of the day. They have legs and they can walk, and they can go to other companies and they take their knowledge with them. Over the years, these systems have been expanded, and you have multiple generations of these systems at plants, and managing their configuration is extremely difficult. While each of these vendors that are listed up here may have a solution for automation system asset management, namely configuration management, none of two of them work together to manage the configuration of multiple systems. And that becomes a significant problem. A typical automation owner in a process plant at the enterprise level may have 30 different systems and applications that they have to manage, and it becomes unreasonable and untenable to have 30 different applications to manage those systems. So what are some things that companies can do to improve their asset management posture as it relates to industrial control systems that are at risk, that are at significant risk of cyber attacks? Well, the very first thing a company must do is to understand what they have. That is the basic inventory, everything from level 0 to what is now coined as level 3.5, the demilitarized zone, the DMZ. Now, it is rather simple to gather the inventory of a listing of devices that are on level 2 that have IP addresses. These are, as I mentioned earlier, Windows devices that are discoverable. However, when you go to level 0 and level 1, controllers and instrumentation, which are now mostly digital, they're very difficult to gather the inventory of. The second aspect of a robust asset management and cybersecurity initiative is to understand asset interconnections. You want to know what devices are connected to any of your controllers or any of your servers at level 2 if they are infected, so that you can quickly identify potential damage that could be done as a result of an attack. Establishing a configuration baseline. This is like a golden copy of what good looks like. And fortunately, for a process plant, an industrial control system is a platform for continuous improvement. That means I've been to a process plant, a refinery, or a chemical plant where control engineers are in the control system every day making configuration changes to improve the process. But that flexibility and that platform for continuous improvement is also a curse, which means your best configuration is your last configuration, what was there yesterday or the day before or a week before. So to that end, maintaining a good configuration baseline becomes a challenge, and oftentimes this task is done manually and it's done once a month at best. Managing changes to the configuration and conducting audits routinely is difficult, and it should be done automatically. Finally, assessing your vulnerabilities, understanding what vulnerabilities you have, from field instrumentation to controllers to the HMI and to the advanced applications, is very, very, very critical. Remediation of these vulnerabilities is critical to the robustness of the ICS and the security and the safety of the process plant. Of course, we don't automatically patch. We have to prioritize. We have to go through a process of understanding what impact would a particular vulnerability have before we implement a correction patch. Finally, the last line of defense, the last resort, is the backup a fresh backup of the system, and the ability to recover, we must assume there will be an incident. Very much similar to the way that if you live in the Texas Gulf Coast, Texas, Louisiana, Alabama Gulf Coast, you must expect at some point there will be a hurricane that will impact you, and therefore you are mandated to have flood insurance and wind insurance. You must assume that at some point you will be attacked or there will be an inadvertent incident that will lead to loss of your configuration. Therefore, you must have a way to recover. You must have a fresh backup. So in summary, I want to highlight that we live in an absolutely phenomenal time. This is the best of times as it pertains to innovation, productivity improvement, possibilities of not only automating but optimizing. I think the rest of the world is waking up to the capabilities of automation, and now it's called IoT. However, with those capabilities and those opportunities out there, we are facing a new threat that didn't exist 10 years ago, 20 years ago for industrial control systems. And that is the threat of cyber attacks on the critical infrastructure from bad actors, be it individuals or gangster groups or nation states. We are under attack. And when I say we in the industrial sector, not just the United States, globally, we are under attack. But there is a way to protect, and there are many things companies can do to protect themselves. Know what you have, know your vulnerabilities, understand the consequences if something goes wrong, and be prepared to recover. So with that, I'm going to hand it over to John and open up for any questions you might have.
Fantastic presentation. I think that was one of the best overviews of this area I've ever heard. So this is, a fantastic job of giving that overview. We're going to go ahead and open it up to questions. If you'd like to, you can put that in a question in the chat window, or you can unmute your microphone. We've got about 10 minutes or so for questions. And I've got one here just to lead us off. So a lot of these industrial control systems are not connected to the internet. How is it possible to have a cyber attack if they're not connected to the internet?
That's an excellent question. The concept of air gapping a system, that's actually become a verb now. Air gapping a system means not connecting it to the internet or to the broader enterprise. And that used to be the premise that if you are air gapped, you're protected. Well, actually, that is not true. Vulnerabilities and viruses, attacks can be implemented in many different ways. One of them is simply by mistake. An engineer from the automation company comes in and says, I'm here to upgrade to the latest operating system on your XYZ control system, and inadvertently carries with her that virus that is going to infect your system. This could be inadvertent, just as innocent as I just mentioned, or it could be schemed up through many ways, including through a carrier agent, where an innocent contractor who has never had anything malicious to do is impacted through an email. His system is impacted, and through that agent, they can enter into your environment and attack your system. So basically, the Trojan horse strategy that can bring viruses to your environment, impacting a process plan. And there are things that companies can do to prevent that, including blocking practically every USB port.
Yeah, fantastic. And we had those types of tests where the IT department would actually drop USB drives outside the plant, and see how many got picked up and put into slots to see what was on them to hopefully return them to the owner. And I think about 40% of them got plugged into the corporate internet. So they instructed us to not do that, to not pick up USB drives and just throw them away. Well, that's really interesting. So So here's another question for somebody who's just entering the workforce. What are some of the things that they need to be aware of as they enter as like an applications engineer?
Excellent question. As an application engineer, there are two aspects that I want to highlight. One is the traditional application engineer role. You must understand the process, get to know your operators, become best friends with them because they know the process better than anyone else. And in order for you to become a good automation engineer, you have to understand the process. And of course, it's a given you must understand process controls and then systems. You have to understand how a system works before you can make it sing. With that said, there is a new capability and a new set of habits that our application engineers need to adopt, and that is cybersecurity. It starts with basic cybersecurity hygiene. Become aware, very much like the way when you go to work for a processing company, an ExxonMobil, Shell, BP, the first thing they do is they pound into you a culture of safety. Those same companies are now doing the same thing with cybersecurity. So understand the basic hygienes of cybersecurity. Don't put a USB stick that you found in the parking lot in a device. Just don't do that. Don't click on emails on every email that comes your way. Be suspicious of everything. But with that said, do yourself a favor, attend a webinar, or read on basics of cybersecurity for industrial control systems. That will help you tremendously in working with the automation folks as well as the IT folks.
Fantastic. Well, that's excellent suggestion there. It looks like, Austin, you have your microphone unmuted. Do you have a question? Okay. Well, let's go on to another one. We have, a lot of different, we think about IoT and we think of, vacuum cleaners being connected to the internet, dishwashers, fridges, and this is all kind of recent. What suggestions would you have for the industry where they are starting to connect devices to the internet? Your vacuum cleaner might have an IP address. What would you suggest as some of these other industries are starting to adopt IoT?
That's an excellent question. That's a question that all of our customers are asking as well. I think the possibilities are just immense. I'll give you an example of IoT that is fantastic, and that is simple RFID chips that we can embed in badges today that not only allow people to get in and out of a restricted area, but also they can indicate and communicate back to a central server, if you will, the location of an employee. So you can track your employees throughout the plant. So if there is an incident, you can very quickly identify where your people are. So the capabilities are fantastic, but that's also a vulnerability. If a hacker hacks into that personnel tracking system and they want to physically enter into the plant, they will know where everybody's at. It almost becomes like a spy novel or a Mission Impossible movie. What you must also do is protect the IoT. With this new vulnerability, yes, it's great to go in and use every one of these capabilities, but be conscious that you are creating a door for the bad actors to come in and take advantage. So protect the IoT, which starts with know what you have. Have an inventory of every IP address, every device that may not even have an IP address. Know your devices, capture their configuration, manage changes, look for vulnerabilities. Apply the same principles that we are applying to ICS or OT asset management to IoT. In fact, this could be IoT asset management and cybersecurity strategies, this particular slide we're looking at.
Fantastic. That's great. I was reading some things about cybersecurity and a survey that was sent out, and about 3/4 of companies state that it is very likely, or at least quite likely, to become a target of a cybersecurity attack in the OT/ICS space. But with this survey, they identified a gap that only 23% are compliant with minimum mandatory industry or government guidance. What are some of the tools or other things that are out there that can help them become compliant with the minimum guidance?
That's an excellent point. Different industries are adopting different standards, but generally they all require what we refer to as foundational security. Foundational security starts with knowing what you have, a complete discovery and inventory of all your assets from level 0 to level 1, capturing the configuration of these systems and putting that configuration under strict management of change. Change is wonderful. Change is opportunity. Change is a platform for improvement, but change can also lead to disaster if it is not managed. So know what you have, manage change on your systems, understand your vulnerabilities, and have a backup so you can fall back upon.
Great. Another question regarding, you started this company and have watched its growth, and now as it's become PAS Global and you've attracted investors and others to really grow and expand the business, and you've entered this cybersecurity space. What have been some of the challenges or opportunities that you've seen as a business owner getting into this space?
That's an excellent question, John. It really is. Wow. When we entered it, there were not many players in this space. We could probably count on one hand companies that were truly OT cybersecurity companies. We came from a background of automation systems integrity as well as operational risk management. So we had to assert ourselves in the security arena, and that was not too difficult for us. People very quickly understood what role PAS can play in security in the OT environment. But what has happened over the last 3 or 4 years, we have had a significant number of companies bringing their successful IT cybersecurity solutions to play in the OT arena. So there's confusion in the industry as to what is needed to perform OT asset management, to identify inventory of these operational technology systems. There has been tremendous amount of money raised. You have companies with revenues below 10 million having spent more than $50 million and still raising $100+ million to play in this market. So on one hand, it is very, very exciting. But on the other hand, our challenge is to get the word to our customers, the broader audience, as to what true OT asset management is about. But they are definitely coming along and they're picking up on that. So sorting out the noise from the signal, your team might appreciate having had some Laplace transformation classes. Sorting out the noise from the signal becomes difficult here.
That's a great analogy, and thanks for that. Okay, so let's see. We got one question, actually 2 questions here. Just came in. If you had to grade the industry on a whole for cybersecurity preparedness, what grade would you give based on your experience? And then what is the biggest hurdle preventing businesses from implementing changes toward better cybersecurity?
Again, that's an excellent question. At the risk of alienating some of our friends and colleagues in the industry, I would say the industry gets an A+ for effort. Absolutely focused. Boards of directors are in there. They are providing budgets. They are making it a mandate that companies address their OT cybersecurity initiatives. The second area of grading, I would say, after effort is rate of adoption. I would give the industry a B for rate of adoption, which involves both budgeting and implementing solutions. And preparedness, based on your survey, the survey that you cited, I have to go by facts. Based on the survey that you cited, I'd say we're at a C minus, with less than 30% of the industry itself declaring to be unprepared. I'd say we're at a C minus in terms of preparedness for cybersecurity.
Thank you. I've got two more questions that just came in on the chat as well. So PIS provides a system for asset management and ICS. Does it have access? So how do you have access to many different brands of OT or IT? How do you manage all of those?
That's an excellent question. These are, as I mentioned, proprietary systems that are not open to your typical calls or API capabilities to access information. What we have done over the last 20 years since the original release of our software, Cyber Integrity is the name of the software, is we have developed adapters, which we refer to as asset models, that model the DNA of these control systems. So the information that we gather from these systems and scan on a regular basis allow us to have insights into these systems. So I would say the proprietary technology that we have is these asset models that gather and interpret the data out of these systems, over 80 of them.
Wow. Okay, that's quite a few. Another question that came in, cyber attacks from nation states seem like they could be considered an act of war, and many have, stated that could be for damaging critical infrastructure. One example being the Stuxnet. So I guess the question here is, let me just rephrase this a little bit. What type of attacks could start these types of physical wars between countries? And I guess a follow-on question, would you consider then that what PAS is doing with preventing cyber attacks helping to preserve world peace?
I love that. I am going to take that. If I can borrow it or if I can use it, we'll pay a fee. We can trademark that. PAS is fighting to keep peace in the world. I love that. And we'll revisit the exact terminology. Look, the world is changing. This is a very insightful question from whomever it came. The world has changed. We are, and I've written about this, we are where I think the world was after World War II, in the 50s. We have found a new weapon. This weapon can cause tremendous harm. Post-World War II, we had the nuclear bomb that could cause significant damage, and people were trying to figure out how to use it and how to develop it. Cybersecurity and cyber attacks on the critical infrastructure can have the potential to become a significant weapon that could attack the critical infrastructure of a country. If you look at what happens immediately after a war breaks out, you attack the critical infrastructure. You attack the roads, you attack the refineries, you attack the platforms offshore, you attack the power plants, power distribution centers. And now you can do that through a stealth method called cybersecurity without ever shooting a bullet from across the world, 10,000 miles away, and not be noticed. And if it's done concurrently and sustainably, it can cause significant harm and lead to an actual war between countries. We haven't seen that. It's been sustained. So to that end, we believe that defensive cybersecurity is absolutely required. But on the policy side, we believe that nations of the world should get together, similar to the way we formed the United Nations, and develop some treaties around attacks that are physical. Yeah, we can play war games with IT systems. But once you start impacting lives, attacking a refinery is no different from a cyber attack on a 747 and making it fall out of the sky. Now, on the policy side, it could be viewed as act of war, something that nations should take very seriously. And I think that is gelling right now. That is in development. Policymakers are looking at that. Very insightful question.
Thank you for that. Very sobering to think about that and the implications. Eddie, fantastic presentation. We're out of time now, but I really appreciate you coming on and sharing some of your thoughts and experience from a lifetime working in this area, and certainly appreciate the question and answers and how you responded to those as well. So with that, we're going to go ahead and conclude this webinar, and thanks so much again, Eddie.
Thank you, John, and thank you, everyone from BYU. You guys are killing it out there. We need more of you to join us in the industry to fight the bad guys. Whether you're in computer science or chemical engineering practices or process control, we can use you to help us defend peace for the world. Just to close the conversation here, we have a shortage of over 1 million cybersecurity practitioners. Just give that some thought and join the fight. And of course, as you know, where there is a shortage of experts, the compensations are much better. Best of luck to you. You are doing good work through automation and optimization, and have a peaceful day. Thank you.
Okay. Well, thanks, Eddie.